as well. So we are recording. There we go. So starting a new unit, and there's a reason that I'm starting off by asking you what you know about energy, because that is going to be one of the key ideas coming back through in this unit. So really, in my mind, kind of three things that we're looking at. Three things that we're looking at for this unit, which are the energy having to do with different chemical reactions. So building molecules up, breaking them down, helping them go faster. All of that stuff is kind of this first section that we're starting with today. Then we get into two types of chemical reactions that our bodies or other organisms use in order to have the energy that we need. So we are going to collectively call this unit bioenergetics. Fancy way of saying the energy of life. This isn't some like spiritual energy. This is, you know, the energy. So today we're going to go over a brief lecture on energy, and then we're going to do something new called a collaborate and discuss. It's really not that much different than what you were starting to do last week, but I'm still really working on trying to find ways that you guys can have that collaboration piece, that you guys can take information that I'm giving to you, kind of ruminate over it, think it through, and come to some of your own conclusions more than me just talking at you all the time, because that will make me completely lose my voice and make you want to gouge your ears out. And then if you finish that, we'll have a little bit of work time. The OpenStax textbook for this unit is kind of meh for just this chapter. So I have the chapter 8.1 notes are posted. They have a different textbook, a PDF attached to it. I would give you the whole thing, but it's kind of illegal and whatnot, so we're going to hold off on that. But the chapter 8.1, 2, 3, 4, and 5 notes, everything from chapter 8 is out of a different text, so make sure you're using the text that is attached. That is the Campbell book. Do not use OpenStax until you are re-instructed to do so. Just some general reminders of what you need to be doing. Make your life easy now. You got notes due tomorrow. It's going to be on energy and whatnot. Make sure that tonight, as you're going through, you put in your unit update, all your terms and like a big idea, just to kind of summarize what we're talking about so far. You have another section of notes that are due Wednesday, and as a heads up, your next test is tentatively scheduled for November 23rd. Additionally, I'm going to try something. Along with this collab and discuss idea, C&D, I'm going to pull back a little on the quizzes and transition more to more collaborative discussions. I'll be taking a look at those at the end of each week and basing participation on partially on that. So what you have in there can benefit your grade. If you are not collaborating with your peers, I will have a discussion with you, and that'll be a no bueno. So let's not go there. All right, any questions so far? Again, big picture here, we're looking at energy. We're looking at the chemical reactions in which energy is going to be playing a key role, and then at some of the particular chemical reactions that are involved in metabolism. So without further ado, we are in the 1026 to 27 Matter and Energy folder, and the lecture is titled Matter and Energy, which is not super surprising. So this guy's a pretty quick lesson. It's only like 9 slides, including the cover, so that's always fun. But like I said, this is going to be the basis of what we're doing for this whole unit. If you walk out of here today not understanding what energy is, welcome to the world. No one does. It's one of the most difficult concepts to kind of wrap your head around. So try to wrap your head around it. I'll try to help you through that, but it's not an easy concept, and I recognize that. But we can start with matter, and that's a lot easier to understand. The way I want you to think of matter is the stuff. Matter is just stuff, okay? Anything that has mass and takes up space is defined as matter. So we're thinking of things like atoms. Simple enough so far? So all of the stuff of the universe is matter. And the law of conservation of mass says that you cannot create it or destroy it in a chemical process. So all of the matter that is on Earth is the same matter that has been here forever, with the exception of, comets and whatnot. So the law of conservation of mass states that matter cannot be created or destroyed. We've heard this before. Yes, pretty simple. Okay. Well, let's move on to the harder one here, is energy. Raise your hand if you feel like you have a decent grasp of what energy is or might be, or, and raise your hand if you're like, that's kind of abstract to my little brain. I have a little brain. It's abstract. It's fine. Okay. So I'm going to start with a whole bunch of definitions, because matter is very obvious. You know what it is. You can touch it. You can feel it. But energy, especially potential energy, is a little bit confusing because it's not something that's innately affixed to an object or to a particular type of matter. So here are the definitions that we're going to work with. We can look at energy as the ability to move something against a force, or to do work, or to move matter. A lot of definitions. So we can either look at matter as the stuff, but then energy is just anything that could move it. Okay. And when we look at energy, there's really two main types. There's either energy that is because the matter is moving or could move. Matter that is moving has kinetic energy. Matter that could move is called potential energy, or has potential energy. Is that making any sense so far? Okay. I am putting energy in to pick up this remote, right? I have to mechanically, physically move it. My cells are doing some kind of work. And as I lifted it, I was doing work. That means I was exerting energy. And that energy that I used was transferred to this object. So now this object has more energy in it than when it was down here. Down here, less energy, up here, more energy. That's kind of weird to think of. But when it's up here, what does it have? Ooh, gravitational potential energy. I could drop it. It has the potential to move. I'm really impressed that I caught that. I'm not the most coordinated person, okay? So energy is constantly being transferred between objects, transformed between different types. And just like when we were talking about matter, energy can also not be created or destroyed in any chemical process. Einstein is a much smarter person, even being dead, I think, than I am now, and pointed out that energy is converted to matter and vice versa in some instances. Whew, don't worry about that. So types of energy: kinetic is matter in motion, potential is matter that could be in motion. So when we look at kinetic energy, if it's moving, what can happen is it has the ability to bump into other stuff and then move it. So the thing moving has energy. When it bumps into something else, that thing gets the energy. It's transferred. Some examples are electrical, thermal, and mechanical. Electrical and thermal are going to be really important in this unit. So if electrons, they are flowing from point A to point B, then that is an electrical energy. Thermal energy is movement of particles. We've seen this already. We're okay with it? But potential energy does get a little bit more confusing, and you just have to keep in mind, if it has the potential to move, if it is in a position that makes it likely to move, then it has potential energy, and if something changes, it will move. Okay, so it can be converted into kinetic energy pretty easily. Things such as gravitational, nuclear energy, and chemical energy. Oh, Miss Unger really seemed to stall before she said chemical energy. Why would that be? Great question, my lovely AP class. When we're looking at chemical energy, that has to do with chemical bonds. And today I want you to start wrapping your head around what chemical energy is, why chemical energy is a form of potential energy, how it can change to kinetic energy, and there's a lot there. So we ready to switch gears and do a little bit of collaboration? Little C&D, collab and discuss. If you go into your group discussion folder, again, that's in the general information tab. I've gone in, I deleted the stuff from last week and saved that as a separate version. And I hope, dropped this document now into your group document, okay? So this is in your group document already. And so in this activity, you're going to be really doing two things. You're going to be looking at covalent bonds. You're going to be looking at the forming and breaking of bonds as they relate to energy. All of this is going to be based on a collab and discuss model. So this is what it looks like. Notice right here, there is a question. You are given instructions. You are given further details of things you may want to include in your discussion. And then there is a summary of the answer, a box on the right-hand side. What you are going to do with your group. Read the question, do the instructions, take whatever time it needs to do that, reconvene, and then discuss. Just like you did last week. Discuss and try to come to an agreement on what the answer is, and then one of you can write it in this area. Okay, let me say that perfectly clearly though. Discuss first, right answer later. Discuss, then answer. Stuff below, stuff here, okay? Any questions on what that looks like? My guess is this is roughly half hour, 40 minutes. I've been known to misjudge things before though, so if it does take a bit longer, we can reconvene and address it at that point. But until then, go ahead and turn this.